Welcome to class of physics. In previous video, we studied out one of the application of operational amplifier, that is phase shift oscillators. Now another application, that is Wien-Bridge oscillator. This Wien-Bridge oscillator is used to produce the audio signals. Okay, that means audio frequency signals. Here, Wien-Bridge circuit is connected to the operational amplifier. Then we can generate the audio frequency signals. And this Wien-Bridge oscillator consists of series RC network and a parallel RC network. Here R1 C1 are series network, R2 C2 are the parallel networks, and R3 is the feedback resistors. So R4 is used to inverting terminal as a ground. The equivalent circuit of this is represented in another diagrams. So we can see the clear of Wien-Bridge oscillator. This is a form of Wien-Bridge oscillators. In one arm there is a series RC network. Adjacent arm there is a RC parallel network, so resistor and capacitor parallel. In another arm there are two resistors R3 and R4. This Wien-Bridge oscillator is said to be balanced when R3 by R4 is equal to R1 by R2 plus C2 by C1. So in this balanced network there is a frequency generation that we call as a resonant frequency, that is equal to 1 divided by 2 pi under root of R1 C1 plus R1 C1 into R2 C2. This is a resonating frequency that is produced by Wien-Bridge oscillator when it is balanced. The balance condition is represented by these equations. Now what should be the values of R3 and R4? Let us assume we are considering the resistors values R1 equal to R2, that is equal to R, and C1 equal to C2 equal to C. Here R1 and R2 resistors, R1 and R2 resistors, these two resistors are the same value. Okay, this is R2 and this is R1, these two are the same values, that is equal to R. And capacitor, these two capacitors are the same values, that is equal to C. In these conditions the frequency value becomes F equal to 1 divided by 2 pi square root of R C into R into C. So F naught resonant frequency, that is F equal to 1 by 2 pi under root of R square C square, that is equal to 1 by 2 pi R into C. And then from these equations substitute the same condition, then R3 by R4 is equal to R divided by R plus C divided by C, because R1 R2 are both are equal to R, so C1 C2 equal to C. These two cancel, so 1 plus 1, R3 by R4 is equal to 2. Then R3 is equal to 2 times R4. This is the one more equations. So what is R3? R3 is here. This is equal, here in these two diagrams there is a little bit changes there. For this is R3 and this is R4. This feedback resistor is always greater than the resistor that is grounded, so that the feedback resistor R3 should be 2 times of R4. Suppose the grounded resistors for inverting terminal is about 2 kilo ohm, then the R3 is minimum 4 kilo ohm, that is feedback resistor is minimum 4 kilo ohm. And what is the gain? Here gain of this resistor, it is in non-inverting mode. For that the gain should be equal to 1 plus R3 by R4, or in other words we can say that is RF divided by 1 plus RF divided by R. So using these conventions we are solving this problem. For that A equal to 1 plus, what is R3 by R4? It is 2, gain is 3. Using these values, one is resonant frequency 1 by 2 pi RC. For to achieve this, we should require minimum feedback resistor should be equal to, or take it as R3 now, should be equal to 2 times R4, and the gain should be at least 3 times. Okay. Using these values, we can configure the Wien bridge oscillators, which produces the resonant frequency 1 by 2 pi RC. So for this, the theoretical concept of this chapter is complete. Now go for the problematic method, solving the problems. So these problems are simple, just based on the inverting and non-inverting amplifier, differential and summing amplifiers, to find its output voltage, or it may be a gain. Now take first problem. In an operational amplifier, inverting amplifier. In an operational amplifier, inverting amplifier. So this problem that related to inverting amplifier. The feedback resistance is 100 kilo ohm and the input resistance is 10 kilo ohm. Calculate the gain of the amplifier. Here the feedback resistance is 100 kilo ohm and input resistance is 10 kilo ohm. Calculate the gain. Write once the given data. The RF is 100 ohm. Then input resistance is R, or you can take it as R1, 10 kilo ohm. We have to find. So the feedback resistance given means it is a closed loop configurations. Let's see diagram. It is an operational amplifier. These two are terminals, inverting and non-inverting. There is a output and there is a feedback. It is inverting. For that, we are applying certain voltage here, and another terminal is grounded. Resistor values are given. It is RF and this is R. For this, the gain of the amplifier is given by gain is equal to feedback resistor divided by the resistance at inverting terminal, RF divided by R1, and there is a negative sign that indicates it is a inverting or phase reversal type. So RF is 100 kilo ohm and R is 10 kilo ohm. It is 10. Minus sign indicates it is inverting. The gain of this inverting amplifier is minus 10. There is no unit for the gain, unitless here. We'll go for another kind of problem. In an operational amplifier, non-inverting amplifier, the feedback resistance is 2.2 kilo ohm and the input resistance is connected to ground to 20 ohm. Calculate gain of the amplifier. Yes. So this problem is related to non-inverting amplifier. The feedback resistance value is given. The input resistance is connected to ground, that is 220 ohm. Calculate the gain of the amplifier. Here the gain is given by A equal to, for non-inverting it is 1 plus RF divided by R1. So 1 plus RF is what? It is feedback resistance is 2.2 kilo ohm and the resistance is 220 ohm. This is equal to 1 plus 2.2 kilo means 2200 divided by 220. So the gain is 11. So like that we have to find the gain of inverting and non-inverting amplifier. Another one is related to differential amplifier. Try to solve yourself these two problems as a assignment question. I'll give the hint to solve this one. Here differential amplifier is given, two voltages V1 V2 is given. V1 is 5 volt, V2 is 3 volt, and R1, R3, R2, R4 is given. So try to draw the diagram for differential amplifier. V out, there is a resistor RF, and here one more differential amplifier. 2 voltages is applied here, R1, R2, R3 and R4. 2 voltages here, P1, P2. So following this diagram, find the output voltage Vout. Next problem, there is a summing amplifier. Summing amplifier. So for summing amplifier, 3 voltages are given. 3 voltages means 3 resistors are there. These all together will be connected to operational amplifier. This is output, and this terminal is grounded. So is there any instead of here there is a feedback resistor. Yes. R1, so here R1, R2, R3 all are same, and P1, P2, P3 is applied. This is RF. Okay. Here feedback resistor is 20 kilo ohm, RF value is 20 kilo ohm, and these 3 resistor value is 2 kilo ohm, and the V1, V2, 5, 3, 1 is given. Now find the output voltage. So these two are take it as assignment. For this unit is completes. Thank you.